In the triangle ABC, so A, B, C, D is the midpoint of BC. So this is BC, and D is the midpoint. So the distance from B to D is equal to the distance from D to C. P is any point on AD. So this is AD, and P is any point on AD. Prove that the area of the triangle ABP, so the area of this triangle ABP, is equal to the area of the triangle ACP. So ACP. So prove that the area of ABP is equal to the area of ACP. So we're going to start by considering all the bases along BC. So this is the line BC, the base of the overall triangle ABC. So the area of the triangle ABD, so ABD, is going to be half times base times height, because that's the area of a triangle. The base of ABD is going to be BD, and the height we're going to label as H1. This blue line here is the perpendicular height. So the area of the triangle ABD is half times base times height, so half times BD times H1. So half times BD times H1. And we know that BD is equal to DC, so we're going to swap the BD for DC, because BD and DC are equal, because D is the midpoint of BC, therefore BD must be equal in length to DC. So the area of the triangle ABD can be written as half times DC times H1. And this is also equal to the area of the triangle ADC. So ADC. Because remember, they have the same base and they also have the same perpendicular height. And the area of the triangle PBD, so PBD, again is half times base times height, the base being BD and the height being H2. So we're going to label this perpendicular height here, this green line, as H2. So the area of the triangle PBD is half times base times height. So half times BD times H2. And again, we're going to swap the BD for DC, because remember BD is equal in length to DC. So the area of the triangle PBD can be written as half times DC times H2, which is also equal to the area of PDC. So PDC. So they have the same base, BD is equal to DC, and they also have the same perpendicular height. So the area of the triangle PDC is half times DC times H2. Then the area of the triangle ABP, so ABP, is going to be the area of the triangle ABD, so ABD, minus the area of the triangle PBD, PBD. So if we're looking for the area of ABP, we're going to take the area of ABD and take away the area of PBD, and that will leave us with ABP. So ABP is equal to the area of ABD minus the area of PBD. And we found ABD is equal to ADC. So the area of triangle ABD we found equal to the area of the triangle ADC. And we also found the area of the triangle PBD equal to the area of the triangle PDC. So the area of the triangle PBD is equal to the area of the triangle PDC. So we get the area of the triangle ADC minus the area of the triangle PDC. And ADC can be seen here, ADC. And PDC can be seen here, PDC. DC, leaving us with APC, which is what we have down here, ACP or APC. So we have proven that the area of ABP, so ABP, is equal to the area of ACP, ACP. And that's what we were asked to prove.